And here we go. We want to talk today about evaluating algebraic expressions. Now, this is one of those math concepts that's really interesting because it's actually really simple. Like really simple. You guys would be like, seriously, it's that simple? But it looks hard. It looks like visual vomit to students, so they panic, freeze up, don't do anything, and never realize just how simple it really is. It's always on the GED, so you'll probably have one or two problems like this, and you could do them simply if you don't freeze up. Okay, so in order to understand what we're talking about, we better define our terms. We're saying evaluating algebraic expressions. So what the heck do these things mean? First of all, evaluating. When I use the word evaluating in math class, it's not just like the general English meaning of evaluating where I'm just thinking about something. It's more specific than that. It means the same. It's pretty synonymous with the word simplifying. And to evaluate or to simplify means to perform the indicated operation. And I'm going to give you a really simple little example because this might seem like a complicated concept, but for example, you guys have been evaluating since elementary school. That problem says 5 plus 3, and if I was asking you to evaluate this or to simplify this, I'm asking you to just do what it tells you to do. Perform the indicated operation. We see the indicated operation here as addition, so do it. That's all that it means to simplify. Follow the signs, obey the signs. So if I were evaluating or simplifying here, I would just say 8. Does that make sense? Mm-hmm. Okay. Okay, so we understand that first word, evaluating. Now, I'm going to jump and I want to talk about what an expression is. I know I touched on this in another class because it is one of the most important skills of algebra that you can tell an expression from an equation. You have got to be, because we do certain things with expressions, simplify them basically, and we do other things with equations, solve them. Okay, so we need to know what an expression is. So an expression is some combination of numbers. I won't stop to explain what a number is. I'm pretty sure y'all are familiar. But operations. So what am I talking about when I use the word operations? I'm talking about all our little math symbols that tell us what to do with numbers. Add, subtract, we multiply numbers, we divide them, we take square roots, we raise numbers to powers. Those are all operations. Make sense? Okay, so we have some combination of numbers, operations, and here's what makes it algebraic, variables. Ladies, what's a variable?
Anything that's not a number, like a letter or a picture.
Yeah, it's a symbol that stands in for an unknown number. A symbol that stands in for an unknown number, usually a letter. We usually use letters. But yeah, absolutely. It's a symbol that's standing in for an unknown number. So I want to give you an example here of an algebraic expression. This is an algebraic expression right here. I told you we'd have some combo of numbers, and indeed we see the numbers 2, the numbers 1 here. I told you we'd have some operations. I see a couple of operations here. We have addition, of course, but we also have, what operation is happening here, ladies?
Multiplication.
Multiplication, exactly. And we, of course, have a variable in this particular problem, x. Now, I want to let you know that currently, right now, as this stands, there is nothing we can do at the current moment. We cannot evaluate or simplify this problem at all. Why? Why can't we? So this is one of the things that separates an A student from a B student. An A student will stop right here, say there's nothing I can do in this case. A B student will spend 20 minutes trying to put these numbers together and do all kinds of nonsense. But I mean, look at this. I don't know what X is. How can I multiply 2 times X? I don't know if X is 7 or 11 or 54. And so I can't, there's nothing I can do but shove 2 and X together real close to say that they're multiplying. I can't get any simpler than that. I can't evaluate that. Does that make sense? Mm-hmm. Okay. Same thing here. How can I add 1 to something that I don't know what it is? I don't know if 2 times X is 54 or 87. And so there's no way for me to sit there and take that answer and add 1 to it because I don't know what that answer is. So I am at an impasse. There is nothing I can do with this problem right now. Does that make sense? Mm-hmm. Okay. What would I need in order to evaluate this or to simplify this? What is the missing information that I need?
The value of the variable.
Bingo. Thank you, Joey. Brilliant. The value of the variable. If I know the value of the variable, I can do this math. And that's what you're going to see on the GED. You're going to see evaluation problems where they tell you the value of the variable. Let's take a look. They might tell you on the GED to evaluate the expression. For X equals 7. And then they'll give you this expression. Okay. Now, like I said, I couldn't add 2x plus 1 before, but now I've been given the key to unlock this problem. I know what the value of the variable is. And so your very first step here should be a substitution step. Now, this is one of those things that even though it's a simple little concept, students screw it up all the time. So I just want to talk to you about the word, what substitution means. When we use this word all the time for teachers, right? We get substitute teachers. You guys have heard it that way before, right? Mm-hmm. So if I am sick and I get a substitute teacher in my class, will I still be in the classroom? No, exactly right. If we substitute another teacher for me, I leave. I'm not there anymore. Does that make sense? Mm-hmm. So when you substitute a number for a variable, the variable is going to be gone. Checked out, exactly. So that is what I'm going to do. I know that X is the same as 7. And so what I'm going to do is I'm going to substitute this X out for a 7. I'm going to write 7 right there. Okay, I'm writing underneath. Now, I'm going to come in, all the things that were the numbers and operations are going to be the same. My 2 is still going to be there. My plus is still going to be there. My 1 is still going to be there. Okay, but we need to talk about these two numbers right here. When I write 2 and 7 next to each other, it looks like the number 27, doesn't it? Mm-hmm. But this didn't say take 20 plus 7. This said take 2 times X. So when you're plugging in, you're substituting in a number, you had better use some kind of a symbol for multiplication so that people don't mistake it for 27. Does that make sense?
Yep.
I will use parentheses because I'm a mathematician. I will not use a little X times sign or you're going to mix up your times with your X's. Are we good with that? Mm-hmm. Okay, and so now I've done my substitution step, and I'm going to just give you ladies the advice that you never pick up a calculator before your substitution step is done, because you'll get these problems on the GED where you can do all the work in a calculator, but students who do their substitution straight in their calculator screw it up all the time. So I highly recommend you write down your substitution before you ever pick up a calculator. Okay, fair enough?
Yeah.
Okay. Now, I'm not going to bother to pick up a calculator because this one's really simple to simplify now. Notice it's not a algebra problem anymore. It's just arithmetic now. We just have numbers. So I'm going to evaluate or simplify by performing the indicated operations in the proper order. So I'm going to multiply before I add. 2 times 7 is 14. Drop what I haven't used. And now notice how I go down, develop that good habit of going down. Don't go across equal signs. And 14 plus 1 is 15. Are you ladies good with that?
Yep.
This is the only new skill we're learning. It's that skill of substitution. I mean, it's that simple. All the rest is just order of operations and arithmetic, the same stuff we've been doing. Okay. Okay. So let's try some trickier GED examples. You know, they like to be tricky. Let's look at
Okay.
different ways they could be tricky. Okay. They could use multiple variables. Okay. So you might see evaluate the expression. For A equals 5, B equals 7, and C equals 11. And I think I have a nice complicated little expression here, enough to make anybody cry. Brilliant. Let's give it a try, okay? So evaluate the expression for all these values, and then I have this expression. And again, this is one of those cases you're expected to be complex like this on the GED. This might not be the type of complexity, but it'll probably be complex. And the mistake students make is they just panic and freeze up right here. Don't panic and freeze up without trying my substitution, okay? So I don't have to call B B anymore. B is not a mystery. I can substitute what value for B?
7.
7. So I'll write 7 where I used to see B. Same thing with C. C is not a mystery. C is what?
11.
11. So I'll write 11 here. Don't forget to use your parentheses. Since those two things were shoved together, they are multiplying. We good with that?
Mm-hmm.
I will keep any symbols like minus signs, any operations, but I will substitute out my variables. So I don't have to call AA, I can call A
5.
5. And again, I will keep my operations like a square, like divide. I will keep my numbers like 2. Is everybody good with that?
Mm-hmm.
That was my beautiful substitution step. Now, FYI, if you have a TI-30 XS, you could actually plug that entire thing in right now, just like that, and it would work all the order of operations for you. It's glorious. Yeah, it's real nice. Did either one of you pick up that calculator?
Not yet.
No, then we get to do it by hand. Here we go. Okay, so order of operations says we should start in groupings first. Groupings, then exponents, then multiplication in its inverse, and addition in its inverse. So remember that the top and bottom of a fraction naturally make a grouping. So I'm going to have to do all the work up top before I can do anything else. Does that make sense?
Mm-hmm.
Okay, there's a couple of operations going on up top, but even when you have multiple things in a grouping, you always want to follow the order of operations. So I'm going to do exponents before I do multiplying or subtracting. So I'll start by doing 5 squared. And of course, 5 squared is 25. I replaced this 5 squared with 25.
Mm-hmm.
I'm going to drop down now everything I have not used. I have 7 times 11 still. I have a minus sign. I have a 2. I actually could have done the 7 times 11 at the same time, since those two things aren't affecting each other, but I'll just try to stay real neat so I don't confuse you guys. Okay. After exponents, we perform multiplication. So 7 times 11, and I'm coming over here because I'm out of space. 7 times 11 is 77. I have not used up my minus 25. I have not used up my divide by 2. Good with that, ladies?
Mm-hmm.
Okay. And one more step, I got to do my 77 minus 25. 77 minus 25 is 52. And I have not yet used up my divide by 2, so it drops. Divide by 2. And now for my final act, I will divide by 2. 2 goes into 5 twice, remainder 1. 2 goes into 12 6 times. That's called sight division, by the way, ladies. I have a video on it on YouTube. It's beautiful. If you don't know how to do it, I highly suggest you watch that video. It's fun. Okay. And so this is now simplified. I've done all the math that I could do. I've obeyed all the operations I could obey. Does that make sense?
Mm-hmm.
Okay. So that's one way they could be nasty. They could give you multiple variables. Okay. Another way they could get nasty is that they could kind of hide this skill in a word problem. So students freak out. Oh my gosh, it's a word problem. So did you guys get this down? Can I clear it?
Yes.
Yep.
Okay. Oh, sorry. I forgot a word. The cost per bike of producing X bicycles is given by the expression oops. You guys are gonna have to put up with me a little bit. Sorry. Okay, I like it. Okay. This is so GED typical, by the way. What is the cost per bike when producing $200 bicycles? Okay. So here I have this nasty expression and students panic and freeze up and they say they hate word problems and I'm cheering. I'm so excited. This is such a simple problem. Why? Because they told me exactly what math to do. They said, you don't have to know how to do any of this math. Here is the step-by-step procedure to find the answer. That's what they did when they gave me the expression. Does that make sense? And they solved the mystery for me. In this very problem, they told me what that mystery letter X is. Anybody see it? Take a look at this final question here. What is the cost per bike when producing 200 bicycles? And if you look up here, I said, this is the cost per bike of producing X bicycles. So what I'm saying to you is that letter X represents the number of bicycles. And there it is. There's our number of bicycles. And so what they've just told me there is that every time I see X, I can replace it with 200. Does that make sense, ladies? So that'll be my first step, my substitution step. These problems always work that way. They give you some gross looking algebra, but they give you the unknown and you just go plug it in and do the math. Does that make sense? Okay, so that's what I'm gonna do here. Again, I'll keep my numbers, but I will switch my variables into the number 200. That X will turn into a 200. I'll keep my plus sign and my 10,000. I'll keep my 20, but my X will turn into 200. Is everybody okay with that?
Yep.
And now I'm just crunching. In fact, mathematicians call these kind of problems plug and chug, because you plug in the number and then you just chug through and do arithmetic. It's not complicated math at all. Okay, so let us plug and chug here. So we will do 35 times 200 first. Well, I know 35 times 2 is 70. And then I'll add the 2 zeros to that, because when you multiply, your zeros accumulate. And to that, I'm going to need to add 10,000. And that's all going to be over. Remember, I can deal with my top grouping and my bottom grouping separately. So I'm just going to deal with my bottom grouping here. I'm going to multiply 20 times 200 in my head because I'm lazy. 2 times 2 is 4, and I'll tack on the 1, 2, 3 zeros. Are you ladies okay with the math that I've done here?
Yes.
Yep.
According to the order of operations, what should I do next?
add the 7 and the 10,000?
Absolutely, we still have that grouping up top. And so 7,000 and 10,000 would give me 17,000. And I need to divide that 17,000 by 4,000. Now you might want to do that in your calculator. And in fact, I think I will, because I got tricks for it, but I don't want to show you all the tricks in one day, or you'll be like, oh, overwhelmed. And I get a really cheap cost for producing a bicycle. Apparently Kate wrote a crappy formula, but out of my calculator, I got 4.25. And I know we're talking costs, so I put a dollar sign in front of that, $4.25. Are you cool with that?
Mm-hmm.
Not too bad, is it? But do you see how you could panic really easily because it looks so gross?
Mm-hmm.
Yeah. So sometimes I tease my students and call these problems visual vomit, because you guys just look at it and you go, oh, you don't even know what to make of it. But don't panic until you try replacing some letters. Does that make sense?
Yes.
Okay. It's interesting because this same skill, even though it doesn't look exactly the same, comes up all the time in geometry when we bust out the GED formula sheet. So have you ladies had a chance to look at the GED formula sheet yet?
Mm-mm.
Okay. So it would be very, very worth it, by the way, to Google that formula sheet and print it out. It's widely available. So you can see that they give you these kind of like step-by-step directions to solve a lot of problems. But if you just panic at the sight of them, you're going to be in trouble. Okay, so here's an example where you see this kind of same skill coming up with the GED formula sheet. Okay, so here's my GED example. This happens all the time. What is this, number 3 or number 4, ladies? 4. I decided. Joey's like, I don't know. Okay. Let us say that a triangle has a base of 4.2 centimeters and a height of 7.3 centimeters. Find the area of the triangle. Now this is a very typical GED style problem. They love area, perimeter, and volume problems, which are all geometry problems. However, they give you formulas to do these. Okay, so if you busted out the GED formula sheet, you would notice that the very first section on the formula sheet, and I should have had it in front of me, I would have if I was thinking about it, I'm sorry, but they're all titled area. And about 2 or 3 of them down, there's the area of a triangle formula. And it looks like this. A equals a number half, a B, and an H. And students just throw up their hands in despair and go, oh crap, I don't know what that means and I don't know how to use it, okay? But now this is not an expression, this is an equation. Do you ladies know how I can tell that it's an equation and not an expression?
Because it says to find the area?
It's actually because of that equal sign. See that equal sign right there with the A equals?
Oh.
All an equation is two expressions with an equal sign in between them. Yeah, you see what I'm saying?
Mm-hmm.
Exactly. You are kind of seeing it here. It tells us to find area, do all that math right there. So that little expression on the right-hand side will find area for me. Does that make sense?
Mm-hmm.
It's not the only way to use this equation, but it is one of the ways. I can use it just straightforward to find area. Okay, and so that is what I'll do. I will do my substitution step first to find area. I'm not going to change my number half because I don't change numbers, but I will just plug in for my B and my H. So we know that the base is how big?
4.2.
Exactly. We see a base of 4.2. So where you once saw B, you can write 4.2. Notice how I write it in parentheses because these things are all shoved together. You cool with that?
Mm-hmm.
Okay, and we also know our height. Our height is how much?
7.3.
Exactly, and so for H, I will write 7.3. And now it's not algebra anymore. Look at that. That's just arithmetic. Those are three numbers I know how to put together. Why not do it? Now, students are like, oh my gosh, I don't know how to take half of 4.2. There's lots and lots of things you can do here. But one of the things you could do is you could just write the decimal equivalent of 1/2. Do you guys know how to write 1/2 as a decimal? How would I do that?
0.5.
Exactly. And so you can just replace that with 0.5. Feel free. Anytime two things are equal in math, you can feel free to substitute one for the other. Okay, are we good with that? Lily, did you know that?
No.
Okay, so if you don't know that, your calculator will also type 1/2. Your TI-30XS will type 1/2 in it, but you need that calculator in order for me to teach you how to use it. Does that make sense?
Yes.
I'll write it down for you in case you want to buy one. It's called a TI-30XS. They usually cost between $11 and $17. And I didn't even realize Bianca was in here. Sorry, Bianca. Hi. We sure can. That's exactly what we're about to do. Bianca asked if we could just multiply across. And that's exactly what I'll do. I'm going to do 0.5 times 4.2 times 7.3. And I get 15.33. Bianca, you were right. And last thing we would want to do here is put a unit. And I will just make a note for you. This is a lecture for another day. But for now, I will just tell you that area is always measured in square units. Bianca tells me she followed the real order of operations. I'm glad, because I have a real problem with PEMDAS. Okay, so here's an example of the same exact skill getting used in geometry. So now we can just have our evaluating expressions problems. We're also able to use it on these more complicated problems on the GED. Is everybody good with that?
Yes.
Okay, gorgeous. The very last example I want to show you is so important. So it's a little tricky because none of you have a calculator, because I am definitely going to do this one in a calculator because I haven't taught you all the skills yet. But I have got to show you something tricky that happens with negatives when substituting negatives. So let's all take a look at this very typical GED style example. So we're looking at GED example number 5. They love to give negatives because they know it screws students up. So we're going to evaluate the following expression. For x is equal to -2 and y is equal to -3. And let's do 3xy squared minus 2x squared y. So once again, if you had this on the GED, you would have a calculator to do your number crunching. The only thing you got to know how to do is substitute, plug in those values, okay? So that is what we'll do. We'll keep our 3, but we'll substitute in the value for x. So we said our x was a -2. And we'll substitute in our value for y. Now this is what I want you to notice. I want you to notice that y is part of an exponential expression. All I mean by it is that y has an exponent on it. Can you see that y has an exponent on it? That is my warning to you. Whenever you plug in a negative number with an exponent, you must use parentheses. It's not just about multiplying. It's about the way exponents work. You will get a different answer. But I want to square this whole number y. So in order to say that I'm going to square the whole number y, I'm going to take whatever y is. In this case, y is -3. I'm going to enclose that -3 completely in parentheses, and I'm going to put the square outside of it. Is that cool? So whenever you plug in a negative value, you put that negative value inside parentheses with the exponent outside. Does that make sense? Okay, cool. And now I will keep substituting. I have my -2 from up here. I have my x. My x is a -2. I will completely put it in parentheses, and I will put the exponent afterwards. And then I will turn my y into a, whoa, yeah, right color, -3. Is everybody okay with that?
Mhm.
Okay, now if you did this substitution part right, literally you can type this exact thing exactly the way you see it into your TI-30XS. It even has parentheses. I mean, you just type it just identical to this and it'll simplify it itself. But since we don't have that, we're gonna have to do the math ourselves. Dang it. Okay, so according to the order of operations, I should start within groupings, but I see no groupings here. Sure, there's parentheses, but there's nothing to do inside of a parentheses. Does that make sense?
Mhm.
Okay, so the next thing after groupings is exponents. So let's hit up these exponents. I'm going to do -3 squared and -2 squared. Okay, so this is why I said that exponents matter, that parentheses matter, I'm sorry. Because -3 squared, when you have the whole thing in parentheses like this, what I'm telling you is to take this whole entire number, all of -3, and multiply it with itself 2 times. -3 times -3. Does that make sense?
Mhm.
Now we know 3 times 3 is 9, but do you guys know that a negative times a negative is a positive?
Positive.
Absolutely. So that's why it matters. We'll have a sign change. So -3 times -3 gives me +9. Same thing here. If I had -2 squared over here, that means the same as -2 times -2. So that will give me +4. Is everybody okay with that?
Mhm.
Now, I used up this and I used up that. I will drop down everything I haven't used up. I haven't used my 3. I haven't used my -2. I'll keep my 9 in parentheses. I haven't used this -2 here. And I haven't used this -3. You cool with that? Now order of operations says to multiply next. I will do all this multiplication and all this multiplication. So 3 times 2 is 6 times 9 is 54. And when you have just one negative, it sticks around. Everybody cool with that? 2 times 4 is 8 times 3 is 24. Now, in this case, I had 2 negatives, a -2 and a -3. A negative times a negative will give me a plus or a positive. Is everybody okay with that? And if you're not okay with that, you could be using your TI-30XS right now. And -54 plus 24 would give me -30. That nasty? Okay. Anybody mad at me? No. Well, good. That's about as hard as they get on the GED. Okay, so unless, does anybody have any questions about any of these kind of problems?
Nope.
Okay. I will send the 3 of you ladies out some worksheets that have these exact kind of problems in case you want to give them a try. Okay. And because the video won't be ready until tomorrow, but then for everybody, I will post up the problems along with this video so everybody can try them. Okay.
Perfect.
Awesome. Great class, guys. Thanks for showing up. I like not talking to myself.